Priyadarshini, good evening. Sanjuvani and Kiran, good evening. Am I audible means please mention in the chat box. Sorry for the interrupt. Here we are having a network issue. Good evening, Magesh. Not audible. Now it's audible. Jagdishwar, good evening. Sai, good evening. I hope I'm audible right now. Please mention in the chat box. Am I audible or not? Yeah, okay. So let's get into the session. So today is day 1 on Power Electronics Masterclass. So this series is 21 days. Okay. So we are providing advanced courses like Python programming and advanced Python programming, and we are providing the VLSI courses and ADAS and Amazon Web Series and battery management system, and recent course of our pantechelearning is NVIDIA AI hardware. So this is all our courses, and I will tell you what is masterclass and what we are doing. So we are offering a variety of masterclasses that help you to excel in your learning journey. And this is the 21 days industrial learning activity. It's conducted through live classes on YouTube only. So if you invest just 45 minutes daily to learn the technology from basic to advanced, so finally you will get e-certificate. Finally you will get receive an e-certificate. So how to attendance? So for the certificate, to mark your attendance in the YouTube live classes during the live sessions, so the organizer will share one Google form link in the chat. So this link is available during the live session only. Also keep in mind the live video will be removed from the YouTube 2 days after the classes. So this is the attendance, how to mark your attendance during the live sessions. Okay, so let's get into the session. And this is the agenda for 21 days masterclass on power electronics. From the day 1, we are going to discuss about the introduction to Matlab Simulink. And day 2 is power electronics introduction in Matlab Simulink. And day 3, we are going to enter into the rectifiers and single phase control rectifiers and uncontrolled rectifiers, and we are also talk about the 3-phase half wave rectifiers. And day 7 to day 12, we are going to discuss simulation of single phase AC voltage controller and introduction to DC converter and buck converters and boost converter and buck boost converter and Sepic converter and cuck converter also. And we will be discussing about the PID controller of DC to DC converters on Matlab Simulink. So from day 13 to day 18, we are going to cover zeta converter and flyback converter in Matlab Simulink and introduction to inverters. We are entering into the inverters, and we are also talk about the bipolar SPWM for a single phase bridge inverter in Matlab Simulink and simulation of 3-phase inverters in Matlab Simulink, and we are going to cover the DC transients, and finally we are going to enter into the DC machines, and we are going to cover the speed control of DC motor in Matlab Simulink. So this is all about the agenda, and now we are going to enter into the day 1 session. So for this entire masterclass, we are using the Matlab Simulink software. So first of all, why we are choosing the Matlab Simulink software for the particular power electronics or ADAS and BMS? Why we choose a Matlab software? Because it's a versatile tool, and also it plays an important role in functioning for the AC drive, particularly for our power electronics. So the third most reason is why Matlab? Because other free sources also available in market. Why we choose MATLAB in the sense we can design and we can test under the same environment. So this is what the main reason. Suppose if you have an idea about you want to create a real world system in the sense, you can implement that idea in a MATLAB. You can implement that idea in a Simulink software. You can create a block diagram for a particular real world system, whatever you want. And you can test that same Simulink model under the same environment. So this is the main reason. So you can design and you can test under the same environment. So this is what why MATLAB is needed for the power electronics, not only power electronics, for a variety of applications related to engineering concepts. So I am going to ask you three questions. So first question is, what is MATLAB and what can I do with MATLAB and who uses the MATLAB? I will tell you one by one answer. So MATLAB, we already know MATLAB is a high-level programming language. So that is one kind of the programming platform that is designed specifically for the engineers and scientists to analyze and design the products and systems that transform our world. So MATLAB is nothing but matrix laboratory. So this is the matrix-based language that allowing the most natural expressions for the computational mathematics. And the MATLAB was developed by Clive Moller, who was a chief mathematician in the MATLAB. And the next question is, what can I do with MATLAB? So what can I do with MATLAB? You can analyze the data and you can develop the algorithms and you can create the models and applications. And who uses the MATLAB? So the millions of engineers and millions of scientists, the worldwide, use MATLAB for the range of applications in industry and also academia wise also, including deep learning, including machine learning and signal processing and communications also. So this is the answer for that, what is MATLAB and what can I do with MATLAB and who uses the MATLAB. So next we will see the Simulink. So what is this Simulink? So Simulink is nothing but that is an add-on on a MATLAB software. That is an add-on software tool that is especially for modeling and simulating and analyzing these systems, analyzing the especially dynamic systems. So it provides you, give you the graphical environment, that graphical interface where you can build your models by connecting the blocks that represents the different components of a system, such as sensors or controllers and actuators like that. So Simulink is widely used in engineering fields. It's like a control system or it's like a signal processing and it's like automotive design. Because it allows engineers to simulate how a system will behave in a real time before actually we are going to building that. So that is what the Simulink. So the next one is state flow. So what is the state flow? So the state flow is another additional tool, add-on software tool for the MATLAB. So this provides a graphical language. So that that includes some transition diagrams and flow charts and state transition tables and also truth tables. So you can use the state flow to describe how the MATLAB algorithms and how the Simulink models reacted to the particular input signals. Suppose if you are going to work on the event-based logics or a time-based conditions in the sense, you can use a state flow add-on software tool. So with the state flow, you model some sequential decision logic and that can be simulated as a block within the Simulink model or executed as an object in a MATLAB. So this is what the main difference between the what is MATLAB and what is Simulink and what is state flow. Let us see some additional applications of the MATLAB. So we have seen already there is a lot of applications will be there, especially the signal processing. The MATLAB is widely used in signal processing for the particular task such as a filtering or some spectral estimations like that. It helps us to engineer to design and analyze the systems that processing the signals like audio or a video or some sensor data, and image processing, computer vision, and especially the MATLAB it supports for the machine learning, artificial intelligence. So MATLAB it supports the development of the machine learning models, especially for the classification of the models or regression analysis and clustering, and we are using the deep learning also. So this MATLAB, it includes the built-in functions for training and testing models, as well as a tool for the data processing also. So these are all the application of MATLAB. And next, I'm going to open the MATLAB software here. So here I'm using the MATLAB software 2022B version. I'm using the MATLAB software for 2022B version. So first of all, I will show you what is command window and what is current folder and workspace. So command window is nothing but this is the command window. You can see this is the MATLAB environment page. Here you can see under the home tab, you can see the new script and new live script, and this is the current folder, and this one is the command window. So this command window, it's where you type and execute the individual MATLAB commands. So it is a very useful for the quick calculations, or if you get the quick results by using the commands, direct commands, getting the immediate results. So how to use this command window? So you can directly enter your command and press enter to execute them. And you can also view the results and interact with variables. So this is what the command window. So next we have a current folder. So this current folder, it displays the files and folders in the current working directory. So it allows you to manage your previously saved files. You can open or saving and organizing some script and data files by using this current folder. So this is what the current folder. Yeah, Deepak, you don't want to buy, or else you can use the free 1 month trial version for the MATLAB software. You don't want to buy. You can use free 1 month trial version. So the next one is a workspace. So what is this workspace? It shows all the variables currently in the memory. So it helps you to monitor and manage the variables that you create or you using during your sessions by using the command window. I will show you how to do that. So the next one is scripting. So scripting, in a sense, you can see under the home page, you can see the new script. So this one, it involves writing and running the script that can be saved as a .m file. So that contains a sequence of MATLAB commands. So basically the scripts are useful for automating the task and organizing the code. This is what is scripting. And now I'm going to back the slide. So we have seen the command window and current folder and also the command history. So command history is nothing but it keeps a record of the commands you have entered in the command window. So it allows you to quickly recall that, and you can reuse the previous commands also. That is what the command history. So now we are going to do some demo in the MATLAB. So when to use command window and when to use script. So go back to our MATLAB software. So I am going to write command in the command window. So this is the command window. So we know that command window, it's an interactive environment where you can enter and execute the individual MATLAB commands one at a time. So that is what the main difference between the command window and scripting. So now I will show you. So now I am going to multiple 7 multiple by 8. Hit the enter. You can see the results. Answer is a 56. So this is what the answer. So this command, it multiples 7 by 8, immediately it displays the result. So the same command I am going to give without the semicolon. Sorry, with the semicolon. I am going to put the semicolon here. Just hit the enter. Here you can't see the results in the command window. So what is the reason for that? Because the usage of the semicolon, it can suppress the output. It suppresses the output. This is what the usage of the semicolon. And next one, we are going to create some simple plot here. I'm going to create the simple plot by using this command window. Later on, I'm going to create the plot in the scripting also. So give first the x value, x equal to 0, colon and 0.1, colon 2 pi pi. So this is what the x values. I'm going to give the semicolon, and next one is the y. I'm going to give the y equal to x, sine of x. So sine of x. Put the semicolon. So next I'm going to use the plot function. So plot of x comma y. Plot of x comma y. Close the braces. Put the semicolon. And just hit the enter. You can see one window here. Yeah, so this is our sine wave. So we are creating the simple plot, simple graph here. So this series of commands, it generates a plot of the sine function. This is what the command window usage. So now I am going to create the scripting. So for creating the scripting, under the home page, you can see the new script. So just click on the script. You can see some editor page here. So we are going to write the scripting. So listen carefully. You are going to write the scripting. When you write the code, it's a very good practice to add the comments. Comments means I'm going to add the percentage symbol. So the percentage symbol is a comments. So that comments that allows you to understand your code and you can refresh your memory when you return it later. So that is what the comments usage. So now I am going to write the scripting. So first I am going to define the x and y data. And next x equal to 1:10 and y equal to x dot square. So that means square of each value in the x. So square of each value in the x. So next we are going to create the plot. Next we are going to create the plot. For that I am going to create a new figure window. That means figure in the sense we can open a new figure window. And next I am going to use a plot function, the same plot function here, the plot of x comma y. Put the semicolon, and next I am going to give the title of that plot. So what is the plot name? Here I am going to use a simple plot y equal to x dot square. So this is the title. So title you should under the single quote. So you have to add a title to the plot by using the title function, and I am going to give the x label and y label. So this is my x label. X label is x and y label as y. So this is my script. So first you have to create the script. So go to the editor page. Here you can see new script window. Just click on this. One editor page will be open here. Next you have to define the x and y data. So you have to write the comments by using the percentage symbol, and next you have to define the x and y data, and you have to create the plot by using the figure, and you have to add the plot, and you have to add the title and x label and y label. So this is what scripting. So now I am going to run this simple model. Let's see, I'm going to run this simple model. So before you are going to run this, first you have to save this. So just save this model, simple example 1. Sorry, simple example 1. So just hit the enter and run this simulation. Yeah, so this is your output. And this is the x-axis label is a x and y-axis label is a y, and we are giving the title of the plot, that is a simple plot y x dot square. So this script, it creates a plot of y with the labels and a title. So this is what the scripting. Okay, this is what the scripting, this is the main difference between the scripting and command window. So then go back to our next slide. So that is, yeah, Simulink example. So we can use a Simulink to model a system, then simulate some dynamic behavior of that system. So I am going to explain the simple example that simulates the simplified motion of a car. So here a car is typically in motion while the gas pedal is pressed. After that, the pedal is released. After the pedal is released, the car idles and comes to the stop position. So this Simulink model, it simulates a basic motion of a car using a simplified logic. I will show you. Okay, so for that I'm going to open the Matlab software. So this is Matlab homepage. Here you can see the Simulink icon. Just click this icon. So just click this icon, create the blank model. Here you can see this is the Simulink start page. You will get a lot of information, block sets, aerospace, and audio toolbox, audio, AutoSAR block set, like that. Okay, so this is the Simulink interface, Simulink environment interface, and here you can see the white color workspace. This is what the workspace, white color board, so that is called the workspace. And here you can see the new button. It will open the new Simulink model, and this is the debug, and this is modeling column and format column. And go back to simulation. So this simulation, it consists of the libraries. It consists of the large block diagrams, blocks under the library browser. So you can click this library browser. You will see the variety of blocks under the Simulink and the aerospace block set, and also state flow and HDL coder, HDL verifier, like that. So I am going to use the Simulink only. I will show you. So the simple logic is, we have to take the pulse generator and gain block. So we need a 4 blocks here. So there is a 2-way if you are going to pick your blocks. So you can directly pick your blocks from the library, or else you can directly use the workspace area. I will show you how to do that one. So just click this library browser. So I need a pulse generator. So go to the library browser search section. Just type the pulse and hit the enter. Yeah, so you will get a variety of blocks. I am going to choose the pulse generator only. So just click this block and right click this block. You can see the add block to our model. So this is the pulse generator. And there is another way to pick your blocks. You can directly use a workspace. So now I want a gain block. So just type double click on the workspace. You can see the search block. Just type the name of your block. So I want a gain block. So this is the gain block. So next I want another one more important block, that is this second order integrator. So second order integrator block. So just type the name. Yeah, so this is the integrated second order. And finally, I need the output block. So there is the out one for the two outputs. So if you are going to connect your blocks, just click the cursor on your particular block. You can see the lines to directly connect to the block. So just place your cursor. You can see the lines and just click that lines. So this is the way you're going to connect your blocks. And just take the another one. Press the control and take the another one. So this is my simple logic. So what we are going to do here? So what is the need of the pulse generator? So we are going to generate the pulse signal. So I am going to generate the square pulse signal by using this pulse generator. So that simulates the pressing and releasing the gas pedal for my model. So when the pulse is 1 in the sense, it represents the gas pedal is being pressed and that causing the car to accelerate. When the pulse is 0, it represents the pedal is being released and the car is no longer accelerating. So this is what the pulse generator. So just double click on this pulse generator. You can see the block parameters. So what are the block parameters? We have amplitude. So that is the height of the pulse. And next one is the period. This is nothing but a time. And next one is the pulse width. So pulse width is nothing but on time of the pulse. So the pulse width it should be represented in a percentage of the period. So that is a 5%. So now I am going to connect to the pulse generator to the gain block. So what is the gain block purpose? It can multiply the input signal from the pulse generator by the constant value. So I am going to change this constant value 1 to 2. Okay. So next we have a second order integrated block. So this purpose, what is the purpose? It integrates the signal twice to simulate the car's movement. So the first integration, it should be the acceleration signal that gives the car's velocity. That means speed. So the second integration, it should be car's position. That means distance traveled over the time. So in a real life, this acceleration, what is mean by acceleration? In real life, that is the that is the rate of change of velocity. So dv by dt. So A equal to dv by dt, that is nothing but acceleration. And velocity is nothing but rate of change of position. So we have to integrating the acceleration once in the sense that gives you the velocity, and integrating the velocity that gives the position. So the same logic applies here. That is why we are going to use the integrated second order block. So finally we are going to see the output. So now I am going to add the scope here. So just click this line. You can see. So just click this line. You can see the add viewer. Just click this one. Just a minute. Just click this add viewer. You can see the Simulink scope, and I'm going to click this scope. You can see some changes in the model. Yeah. So we successfully added our scope here. So the same way, just click this line and go to the prepare and add the viewer. Yeah, click the scope. Okay. So all set. So I'm going to tell you the overall simulation logic. So when you start the simulation, the pulse generator, it sends a pulse signal that representing you are pressing the gas pedal. So the gain block, it multiplies or it scales the pulse signals to simulate the acceleration of the car. So what is the purpose of the second order integration? It integrates the acceleration to first give the velocity, then the position of the car over the time. So this scope block, you can see that displays the position output as a ramp, and also it's showing as long as the gas pedal is pressed, the car continues to move forward, and its position, it will be increases linearly with time. So I am going to run the simulation now. So go to this run section, just click this run. Let's see the output. Yeah. So the first waveform is X. So what is the X? X is nothing but a position. So that represents the position or distance that traveled by the car. So just click on the scope. Yeah, you can see this is your output. So when you integrate the velocity with respect to time, you obtain the position X, that means distance. So this second order integrated block, it will give the position of the car. So dx by dt is nothing but, so here you can see dx is nothing but, that is the velocity. I will show you that velocity also. Yeah, so this is the velocity. The first waveform, that is a ramp signal from the position, that means distance. So this ramp, it indicates the car's position is increasing steadily over the time. So which means the car is moving forward, right? So the position is increases because the velocity is positive. I will show you the velocity speed waveform. Yeah, so this is the second waveform. So this is likely velocity dx by dt waveform. So the initial rise, here you can see the initial rise. It represents the cars accelerating from a stop position. So when the pulse signal is applied, after the rise, the velocity remains constant. So that indicating the car is now moving at a constant speed. So this is what the simple model of a Simulink. So do you have any doubt in this? Do you have any doubt? Do you have any doubt? Means please mention in the chat box now. I will explain you once again. Do you have any doubts? Okay. Yeah, Shobha, you can check your internet. Windows graphs not visible. Okay. Is it visible now? So you can use a recent version, Suresh, you can use recent version for your. Okay. Okay. So let's get into the next one. So this is the Simulink example. So next one is the state flow. So as I told you, so state flow, it consists of the some state transitions and truth tables like that. So now I am going to give the state flow explanation. So go back to our Simulink. I'm going to delete all this and go to the library browser. Sorry, go to the library browser. So just type the state flow. Yeah. So under the state flow, you can see the chart. Just click on this add block to our model. Okay. So this is the state flow chart. So just double click on this. You can see one colored window. So here I am going to create these states and add the transitions for that state. So here you can see this is the state. So from the object palette, click the state icon and move the pointer to the chat canvas. So this is the canvas. So this is the canvas. So just click on this. You can see this is a state. So a state with its default transition appears. So this is the transition. And now I'm going to add this one on, and y equal to x, put the semicolon, and next I'm going to add the another one block, another one state, and this is the off. And this under this off, I am going to give the y value as 0. Okay. So before we enter into this state flow, I am going to tell you the internship information to all of you. Just a minute. So you can convert the masterclass, 21 days masterclass, into 1 month internship. So this is the internship on power electronics. So what are the benefits you will get due to this internship? In the sense, you will get 30 days, not 20 days. So this 21 days free live sessions only on YouTube, and 30 days you will get the recorded sessions, recorded content, and you will get the 30 days PPT and exclusive simulation files. You can download that files, and you will get VIP community group, and you will get the IETE internship certification, and 90 days of LMS course access and assignment and weekly live sessions, and also you will get the resume building and mock test and internship and participation certificate. So if you want only the power electronics internship, in the sense, this is the actual price. Actual price is 1,999, and we are offering a discounted fees, that is a 799. So we are offering a discount. So this one is for a limited time period. So this internship, it ends on 31/8/2024. So the next is, we are offering another one bundle. So this is a 3-in-1 electric bundle. So with this bundle, you will get the 3 big masterclass. One is renewable energy, another one is Matlab Simulink, another one is power electronics. So the actual price is 2,999, and we are offering a 1,199. We are offering a discount for this particular 3-in-1 bundle, and this also only for the limited time period. That is this offer ends on 31/8/2024. So what are the benefits you will get through this internship? In the sense, you will get 90 days recorded sessions, 90 days presentation PPT, and exclusive simulation files, VIP community group, and internship confirmation letter, and 1 year validity in the LMS portal. And next you will get the assignments, and you will get weekly live sessions for this particular 3-in-1 bundle. And you will get not only 1 certification, you will get 3 internship certification. So this is all about the benefits of the internship. So if you want only the power electronics internship, so this is the discounted fees, just 799. Use this registration link. And if you want a 3-in-1 bundle, so use this registration link to join as an internship user. So Avina's LMS portal is nothing but our recorded video will be uploaded on that portal. So you can watch by your time. Do you have any other doubts? Do you have any other doubts? Means please mention in the chat box. Do you have any other doubts particularly on LMS? So Sandeep, LMS is nothing but that is one kind of the portal. We are giving the recorded sessions through that portal. Yeah, recorded session is available, Gupta. Deepak, if you want MATLAB software, means you can use 1 month free trial version. Yeah, definitely you can do projects. So if you want internship in the sense, you will get the exciting benefits because you will get the assignments related to our projects and you will get the weekly live sessions, hackathon sessions. That means doubt clarification sessions. Yeah, Neurons, the coordinator will contact you about this offer. Okay, so go back to our session. So this is a state flow. Now I'm going to add the transition here. You can see, just place your cursor on the state. You can see the one arrow. So that is the transition. So I'm going to add the transition and give the condition also. So x greater than t naught. So this is my condition. And the next condition is, yeah, so this one, that is the x greater than equal to t naught. And here I'm going to change the greater than to less than. Okay. So this is my condition. So now I am going to resolve my undefined symbols in the state flow chart. So before you can execute your chart, you must define each symbol that you use in the chart. So you have to specify the scope, for example, input data, output data, or local data. So for that, go to this modeling tab. Under the design data, you can see the symbols pane. So in the symbols pane, undefined symbols are marked with the some error badge. So this is what the error badge, that means undefined symbol. So I'm going to resolve that one. So here you can see, just click this one. So it automatically change the input and output based on our state flow chart. So here you can see, so this is the type of the data. So I'm going to change the input data type to the constant one. So this state flow editor, it resolves a symbol x and t naught as the input data, y is the output data. So x is the input data and y is the output data. So based on the threshold t naught, that does not change during the simulation. So change its scope to constant data. So I am going to give the value t naught as a 0. Okay. So just close this one. Go back to our model. So this is the chart. So our chart is ready. So we are going to give the input and we are going to get the output. So here I am going to give the input a sine wave. So this is my sine wave. Sorry, I need a sine wave block. Yeah, so this is a sine wave. And the sine wave block, just double click on the sine wave block. You can see the parameters, amplitude, bias, frequency, and phase and sample time. So I am going to give the sample time as a 0.2. And connect the sine wave to export. And just take the scope. So this is my scope. I am going to connect the input. And also I am going to connect the output. Okay. So what is happening here? So the sine wave block, it generates the sine wave signal that is labeled as a x, as an input. So which is fed into the state flow chart. So this is my state flow chart. And inside the state flow chart, we have two states. One is on state, another one is off state. So on state, if the sine wave is greater than or equal to the threshold value, so the output is equal to y equal to x. So x is nothing but the sine wave value. And you are taking the off state in the sense, if the sine wave x is less than the threshold value, the output y is set to 0. So this is what my state flow. So this entire model is designed to filter out the negative part of the sine wave. So which effectively rectifies the signal. So let's see. Now I'm go back to the Simulink model. I'm going to run the simulation. Let's see. It will take time to complete. Okay. So our simulation is ready. So just click on the scope. It will display the output. Okay. So go back. Just click the view and select the layout. Yeah. So it's perfectly rectify the negative signal, negative value of the sine wave. Okay. So this is what the state flow. Do you have any doubt? So what is happening here? So just click on this chart. You can see now you can see some animation here. So just click this simulation run button. You can see. Yeah. So here some animation will be happen. So what is that? So that is what the from on to off. When X falls below T0, from on to off. From off to on when X greater than T0 or greater than or equal to T0. So this is what the state flow. So now I'm going to continue the, okay. So before you are going to enter into the power electronic simulations, first you should know the solver. So what is the solver? So what is the solver? Anyone? So do you have any idea about this? So please give just 5 minutes. What is meant solver? What is mean by solver? What does it mean? Yeah, okay, I will tell you. So solver is nothing but you are going to solve one equation or you are going to solve any problem. So inside this Matlab, entirely the Matlab software, we are using the solver. So solver is nothing but our model, our entire model. It can act as a one equation. We are going to get the results. We are going to solve that equation by using the solver types. So that is particularly variable solver and fixed solver. So we will get the better results by using the solver. So that is why we are going to use that one. So there are two types of solvers. One is fixed solver, another one is variable solver. So fixed solver is nothing but, okay, I will tell you. So fixed solver and variable solver. So variable solver is nothing but the step size during the simulation, it should be varied. So the step size, it can change during the simulation to maintain the accuracy. So the variable step solvers adjust the time intervals based on how the model is behaving. If things change quickly in the sense, then solver uses the smallest steps. If things change slowly, it uses the largest step. This is what the variable solver. Here the step size is variable. So coming to the fixed solver, this fixed step solver, it solves the model at the regular time intervals. So that means the step size, it should be constant here. So step size is this time between each simulation point and that stays the same throughout the simulation. That means constant. The step size, it should be constant. So when to use fixed solver, when to use variable solver? So if you want consistent timing or a consistent plan to use your model in a real-time application. Suppose if you are generate the code from our Simulink model, at that time you can use this fixed solver. So that is a very good choice. Or else you can use a variable solver. So when you want a balance between the accuracy and speed and you are not working with a real-time hardware, at that time you can use a variable solver. So this is the main difference between them. So fixed step is nothing but constant time intervals, that is good for the real-time applications. Variable step is nothing but that is a flexible time intervals, that is good for the faster simulations when a real-time performance is not needed. Okay, so this is the main difference between the variable and fixed. So I will give you the list of commands that is used in a MATLAB. So CLC means that clears the command window. So you can enter the CLC in a command window that clears the command window. And clear in the sense it removes all the variables from the workspace. I will show you. So go back to command window. So just type the CLC. Here you can see the command window, it clears. And I'm going to type the clear, and that one it remove all the variables from the workspace. So this is what the commands, and here you can see the close all, it closes all the figures, and figures means it creates a new figure window. So next one, list of commands in the Simulink. So this is the sim of a model name. So that means you can run the simulation of a specified model by using this command. You can run the simulation and open the system by using the open system and close the system using the close system. And also you can get parameter and set parameter. So next one is the state flow commands, that is a SF new. That means it creates a new state flow chart window. SF open means that opens a specified state flow chart. SF close, that closes specified state flow chart. So this is all about the list of commands that uses for the state flow. So I hope you all enjoy the session. So do you have any doubt means please mention in the chat box now. I will answer the questions. So thanks to everyone who joined today's session. This is all about the day 1 Power Electronics Masterclass series. Yeah, thank you, Soumya. Thank you so much. So thanks to everyone who joined today's session. Thank you so much. Yeah, we can use power system branch also, Shushil. We can use not only power electronics, we can use power system and image processing, signal processing, like that. So Shital, this is not downloadable. You can use free version. So this one is a paid version. Yeah, thank you. Thank you all. Thank you so much. Thanks for your time. Thank you all. We will meet tomorrow.